So, but let me go back to lithium ion and say my average cost is between 4 rupees to 460, 395 to 460 with 30%. If I change that 0.3 to 0.5, my cost goes up. It goes up between 5 rupees to 6 rupees. Even that is not too bad. But I know I am not in a hurry. If I start with even 30% today, by the time I build all the storages that are required, lithium ion battery storage and whatever storages, it takes several years. The cost of battery is coming down. As the cost comes out, I can use for 50% and then also get the same cost of 4 rupees to 4 rupee 50%. I think 4 rupees to 450 is achievable in long run. We can go down below that, but right now let us assume that. And this is a picture of the research park, 1.2 million square feet. And we have 40,000 such complexes in the country today, all over, mostly in cities, all big cities. Large buildings consuming lot of electricity. We consume about 25 megawatt hour per day. It is going to go up to 40 megawatt hour per day. There are lots of 40,000 such buildings. Most of them are paying approximately 11 rupees per kilowatt hour average cost, and that includes of course the cost of diesel generation at 22 rupees per unit. Can I do something with them? That is what we are taking up at research park. At research park we say we are generating of course rooftop solar. Rooftop solar is low cost, more like 3 rupee 50 or 4 rupees, but I can only generate so much because my rooftop can only have so much space. So, 10 to 15%. That I generate between 3 rupee to 350. So, that helps me. But what about the remaining? There is fortunately a policy of Government of India, started about 15 years back. What is called that organizations like Research Park, any entity, commercial entity, can set up a captive solar and wind plant somewhere else. Rooftop I have no space. So, I can set it up 100 kilometer, 200 kilometer, 300 kilometer, even 500 kilometers away. And then wheel the energy. The energy generated from that solar and wind plant, I can bring it to here. Of course, solar and wind energy, whenever it is available, I need to bring it. That cost, including the cost of the plant, now I am going to not set up gigawatt, I will go to set up 2 megawatt, 1 megawatt, 4 megawatt plants. These will be somewhat expensive, I will not get 2 rupees, today the market price is around 3 rupee 50 paise, 3 rupee 60 paise per kilowatt hour. It will go down, but today that is the market price. Of course, I have to use it for 25 years. I may have to put in a small investment also, but that is very small. Then I have to transmit it through, what do I transmit? There are long distance transmission line and the power distribution company, DISCOM it is called in India, their lines, I have to do that and they will charge me. They charge me 90 paise per kilowatt hour approximately, it varies, but so by 360 plus 90, 4 rupee 50 paise, plus power distribution company also charge me what is called demand charges. Demand charges is from the grid, what is the peak, depends on peak electricity that we are going to draw. We say we will never draw more than 4 megawatt hour. So, therefore, 4 megawatt hour, that is what Research Park has done, they charge me close to 10 lakhs rupees per month, about a 1.2 crore rupees per year. I have to divide by all the electricity that I consume. Today, that amounts to 2 rupees per kilowatt hour. So, whatever I am paying, I am actually paying to them around 8 rupees plus this 2 rupees demand charges, 10 rupees is what I effectively pay. Now, when I put my battery storage, I can control my demand charges a little bit more. When I am reaching peak, I do not draw as much, I actually start using from the battery, and in which case I can possibly bring it with lot of management, lot of work is required, to 1 rupee per kilowatt hour. This is the goal, this is not something that we are getting. So, we believe that we can get 360 plus 90, that is 450 plus 1 at 5 rupee 50 paise we can get. This is as and when generated, I have to bring it. So, but if I bring it whenever it is generated, what if there is excess generation and I do not use it immediately? I have to put storage. So, research park decided I will put 10 megawatt hour, 10 plus megawatt hour, that is what is the capacity that we have computed, both lithium ion plus chilled water storage. We have already built 2.5, lithium ion we have built 7.5, a little more, we have not decided, and that is what we can of course explore all other form of storage, what is commercially viable, and we will do full energy management. This is the task that our research park has taken up. Now, we have done the computation. If I build a 5 megawatt hour storage, my cost was coming to around 6 rupee 50 to 7 rupees per kilowatt hour per unit. And if I use 70%, assume that 70, whenever energy generated, I can use 70%, only 30% I will use through storage. My average cost for this is 2 rupee 10 paise through storage. So, now what do? I have to take solar and wind cost average plus transmission, wheeling and distribution cost plus demand charges, which is coming to 5 rupee 50, and then for 70% to be used directly and 30% to be used through storage, I have a 2 rupee 10 paise. So, my cost works to 7 rupee 60 paise per unit. And if I am going to use this, I do not need diesel generator. Why? Because there is a storage. Whenever there is a power cut, I will use diesel. That. So, essentially, as compared to 11 rupees, my cost will be 760, maybe 8 rupees per unit. I save money. Please see the importance of it. If I now generate only solar and wind, whatever I need, and wheel it to the campus, I will save money, including the storage, depreciation and operation cost. It is a very, very big thing. If I can do in the research park, and this is the work that we are doing, it is kind of R&D work right now, but we will have these numbers in about a year's time. Then we can do it in every building, every 40,000 building, each of the 40,000 commercial building, all of them will save money and all of them will, and I have already taken 10% interest cost. So, in fact, India would have moved considerably towards this. So, this is what I am talking about. Financial will improve over time, because today we are paying 2 rupee 75 paise, 3 rupee 50, it will fall down, because base cost is only 2 rupee, remember 2 to 250, solar is 2 rupees. Transmission and wheeling, I am today paying will be under 2 rupees. My storage cost will also come down, even with 50%, maybe 175. So, I will actually probably be able to do it at a lower cost, more like 6 rupee 50 paise per unit. And as I am able to do this, and it completely eliminates diesel generator, storage pays for it. It is not just the buildings for commercial building, because if I can do it at around this kind of cost, then why not do it for industry? Why not do it for large housing, urban housing complex? We pay 6, 7, 8 rupees. And we have added advantage, all of this will be fully renewable. We can compute, and probably 60-70% of our usage is industry, the commercial complex, other large government building, educational institutes, and large urban housing complex. This is probably 70% of usage. Do more thorough calculation. And if we can get even 70% to 80% through renewable, we are already 50% of our electricity is through renewable. And as we start reducing coal usage and gas usage in industry, again we can increase this further. This, remember, this is profitable. What magic I have done? Of course, there is R&D and cost computation, all those things are required, but this will do it next couple of years time. At IIT Madras Research Park, we are doing this. The magic that I have done is that I am not dependent on the government to do this for us. When government has to spend for this large plant and they want to set up the storage, their budgets are limited, and a lot of it is spent in variety of things. There will always be tussles about using it here. And therefore, governments sort of say, well, this is not a priority. We are not the biggest polluter. We are only 103rd in the world per capita. What we did is that, however, the damage everybody knows. So we did it, we took it, we say we start with commercial buildings. Now, what is the advantage of commercial building? Commercial building is upper middle class user of commercial building, builder of commercial building, the business is upper middle class of India. They have cash surplus today, or they can easily borrow money at low interest rate. They do not need to depend on the government. I have shifted the onus of driving renewable energy from the government and their power generation companies which are cash starved to corporates which are cash rich or easily borrow money. And for them, branding that I am renewable energy will make a difference. Industry similarly is relatively in better situation, can borrow money. Or large urban housing complex, big ones, upper middle class, they will get additional branding that we are fully renewable, and India will move towards it. This is a strategy that India should follow, and we can get there. The next two slides, what is the size of the storage that I need at research park or any of these commercial building, and I start looking at what is the solar and wind generation. Now, this solar wind generation is pretty much throughout India is something like this, starts at 6, ends at 6, and it peaks up somewhere. It may vary from day to day slightly, cloudy day the number may come down, but if it is there, it is pretty much like this. This is the average. Wind, we do not have a clear idea, depends on which wind, which month, but still we take some kind of a day, within day variation. It is wind is better in the evenings and nights, slightly poorer in the mornings, picks up in the evening. By and large, this is true. So, based on this number, and we can redo these numbers, we have tried to compute what is the storage required. If this is what I will get on the average, suppose there was 2 megawatt hour of wind, 2 megawatt of solar, I will figure out what you have to do, and short term storage, I am calling it a short term storage within a day, matching load and demand. I can get roughly my 2 cycles here, and I can compute when will the my storage be required, what is the size. I do not want to waste even 1 watt hour of energy. So, my storage should, whenever there is excess, my storage should never be full, and whenever is deficit, storage should never be empty. And if I match that, I can compute the total requirement, which we have done. That is where the 10 megawatt hour, 12 megawatt hour that I talked about, maybe 15 megawatt hour will take care of within day short term variation. There is another variation that I need to take into account, and this is long term variation. And again I am plotting here 2 things. What is the solar generation, all solar generation throughout India over the 12 months. And if I see, yes, there is a little bit of dip in January, peak winter months, but more or less, and there is a little bit of dip during monsoon, but more or less it is constant. So, solar is more or less constant. So, more or less I can use it in within a day or within 2-3 days, even in the monsoon period. If it goes down a little bit, next day or the day after it will pick up. Not so for the wind. Now, of course, wind varies a bit from place to place within India, but the total wind generation peaks from around May to August. Not too bad during September, October, but after that it goes down and goes to somewhere in October itself, towards the later part, you get the poor wind. For this, you need your peak generation is 4 months, your decent for 3 months, poor for 5 months. So, you need long term storage. How do you get that? That means you store the energy and keep it for 3 months. My lithium ion battery cannot do this, my chilled water storage cannot do that. This is where there is a problem. Now, of course, one can use less wind, more solar, that is what is going to happen, that will help, but still there is a problem. And what we need is some longer term storage. That is where we will go back. Can I use pumped hydro? Can I, those 4 months when there is surplus, can I pump lot of water? Then I need a huge tank, huge this thing. Can I use compressed air? Compress the air and store it underground, quite some time. Can I use hydrogen? It may not be very good, but at least for this long term, does it work? Lithium ion batteries are not suitable. Are there other chemistries? And we are certainly starting to discover there are other chemistries of batteries. That is some work that we need to do. We do not have immediate problem. We need to, but 5 to 7 years, 8 years, we need to have answers. Otherwise, we can't get to 100%. We will probably get stuck to 60-70%, but 60-70% is not bad, but that is what we need to do. So, there is more assignment question, and I am coming to my last part of this chapter, going beyond solar, wind and lithium ion and chilled water storage. What should India do?